Architecture of 8086 microprocessor. It is divided into bus interface unit and execution unit. The major reason for the separation is to increase the processing speed of the processor. The bus interface unit has to interact with memory and input-output devices in fetching the instructions and data required by the execution unit. Execution unit is responsible for executing the instructions of the program and to carry out the required processing. Bus interface unit perform fetching instruction or data from memory, write data to memory, write data to port, read data from port. The bus interface unit makes the system bus signal available for external devices and the peripherals. The bus interface unit has instruction stream byte queue, set of segment registers, instruction pointer. It contains circuit for generating physical address. First, we'll discuss about instruction stream byte queue. To increase the execution speed, bus interface unit fetches as many as 6 instruction bytes ahead of time from memory. All the 6 bytes are then stored in first out 6 bytes register called instruction queue. Then all bytes have to be given to execution unit one by one. This prefetching operation of bus interface unit may be in parallel with the execution operation of execution unit, which improves the speed of execution of the instruction. Segment registers. To complete 1 megabyte memory is divided into 16 logical segments. Each segment contains 64 kilobytes of memory. There are 4 segment registers that hold the base address or starting address of particular memory segment. Code segment register is a 16-bit register. It holds the starting address of code memory segment. Stack segment register holds the starting address of stack memory segment. Data segment holds the starting address of data memory segment. Extra segment register holds the starting address of extra memory segment. So in this way, the segment register, all are of 16-bit, hold the starting address or base address of particular memory segment. Instruction pointer. It is 16-bit register, always point to the next instruction to be executed within the currently executing code segment. So this register contains 16-bit offset address pointing to the next instruction code within the 64 kilobyte of code segment area. Its content is automatically incremented as the execution of next instruction takes place. Physical address generator. 20-bit physical address is generated with the help of physical address generator circuit by using the base address of the memory segment and the offset address. By the combination of the base address and the offset address, 20-bit physical address is generated. Next is execution unit. The execution unit is responsible for decoding and executing all instructions. Execution unit has control system, arithmetic and logic unit, operands, flag, general purpose registers, pointer register, index register. Control system is responsible for all the coordination of all other units of the processor, perform various internal operations. ALU perform various arithmetic and logical operations over the 8-bit data and 16-bit data. The instruction decoder decode the instruction fetched from the memory to generate different internal or external control signal required to perform the operation. This is done in the control system. Control system will decode the instruction and generate different timing and control signal to perform the operation. Then general purpose register are AHL, BHBL, CSCL, DHDL. All these registers are of 8-bit and can also be used as a 16-bit for general purpose job. Flag register. Flag register reflect the result of execution by the arithmetic and logical unit. Flag register gives the status of the result. Operand register, it is temporary register. It is not used by the programmer, it is used by the processor itself. In case of exchange instruction, if there is data to be stored for the temporary purpose, processor use that operand register in such cases for the temporary storage. Then stack pointer, base pointer, source index, destination index. Stack pointer is 16-bit register pointing to program stack. Base pointer 16-bit register pointing to data in stack segment. Base pointer register is usually used for base index or register indirect addressing. Source index is 16-bit register. It is used for index, base index, register indirect addressing as well as source data address in string manipulation instruction. Destination index is 16-bit register used for indexed, base index and register indirect addressing as well as destination data address in string manipulation instruction. Execution unit perform execution and pass the result to bus interface unit for storing them in the memory.